Hey students, in this video we're going to look at how to calculate total change using integration. So after watching this video you should be able to calculate the total change by integrating instantaneous or marginal rates of change. Key things to remember: fundamental theorem of calculus, we've always been coming back to it recently, to find the area underneath a curve, and also remember all our integration rules. We might be using those depending on the sort of problem that we end up having to solve. Alright, so big thing to remember is that fundamentally integration is about adding a whole lot of values. That's what the S was for. It was a sum of an infinite number of areas all added together. Now, what we're doing when we are anti-differentiating is we might be adding all of these very, very small rates of change. We're adding a bunch of rates of instantaneous changes over a time interval, and the sum means we get to add all those changes together and work out, hopefully, what the total change is. So, if we integrate a derivative, if we integrate a gradient function, what we're doing is adding up all the changes over some interval and working out what is the total change across that interval. Now in economics we call this marginal rate of change. And basically the marginal rate of change is asking, well, how much does it cost to produce the next item? How much does the cost change by? What is the change in cost if we produce one more item? So if we want to find the total cost of producing a certain number of items, then we would need to work out the integral, or the sum, of all of the derivative of all the changes and add them all together. And that's what calculus lets us do. It lets us sum, it lets us add up all of these instantaneous rates of change, all of these marginal rates of change, and adding them all together will give us our total cost. Or if we're looking at revenue, the marginal rate of revenue would be how much extra revenue do we get by selling one more item, and integrating that, adding up all of those marginal rates of revenue together, will give us our total revenue. Alright, so let's work out this one as an example. We've got a rate of change for some water that's leaking out of a container, and if we want to work out the total amount of change, we will need to integrate. So in this case, we've got our function here, we've got our rate of change. So the change in volume is going to equal the sum of, or the integral of, from 5 to 10 of our function -10 plus 2/5 t. We're going to have that with respect to t, because t is my independent variable there. And then integrating that, that'll be -10t plus 2/5 t squared over 2. And that's going from 10 to 5. That 2 and that 2 will cancel each other out. So all we're looking at is -10t plus 1/5 t squared from 10 to 5. Substituting that in, -10 times 10 plus 1/5 times 10 squared, subtract -10 times 5 plus 1/5 times 5 squared. Alright, and that's going to equal 10 times -10 is -100. 10 squared is 100, 1/5 of 100 is 20. And then subtract, well, 5 times 10 is 50, so -50, and subtracting -50, that's the same as +50. 5 squared is 25, 1/5 of 25 is 5, so we're going to minus 5 there. And we end up with, what's that? -30, and so -35 liters. So across that time between 5 and 10 minutes, this container has lost 35 litres of water. And basically what we've just done is added up all of those small rates of change to find the total change over time. Right. Another one here we can do with tech. Alright, so in this one what we'll have to do is, well, we're given the marginal cost function. So this will be the cost of producing the 100th item or the 99th item if we substitute in 90. And we've been given a range here of 0 to 200. Now, the cost of producing the 100th item, well, that one's easy. We just get the substitute in 100. So the cost is going to be, you see the x equals 50 minus 4e to the 0.02 times 100, which is going to equal $20.44. So that 100th item is going to cost $20.44 to make, basically. Now if we want the cost of producing the first 100 items, we'll be integrating from 0 to 100, 50 minus 4e to the 0.02 x dx. And again, this is a tech problem, so we can just put it straight into our calculator, and we end up getting $3,722.19. So significantly more for 100 pieces, but that number makes sense. We're just adding together all of those marginal costs for the first 100 devices or machines that are being made, and that integration sign, that operation, helps us add all of those together. Alright, so students, after watching this video, you should be able to calculate the total change by integrating instantaneous or marginal rates of change.